So our first set of problems are all going to be about significant figures. Significant figures. The first one, 890. 890. Is the 8 significant?
Yes.
Okay. Okay. The 8 is significant. Is the 9 significant?
Yes.
Okay. How about the 0 in this case? Is the 0 significant?
No.
Okay. Why is the 0 not significant?
Because no decimal.
There is no decimal. So I'm going to write here, no decimal. Okay. That's what makes that 0 not significant. So 2 sig figs. The next number, 9,010. 9,010. Is the 9 significant?
Yes.
How about this 0 beside of the 9?
Yes.
Okay. How about the 1?
Yes.
How about the 0 after the 1?
Yes.
Okay. I hear some disagreement on this one. This 0 is significant. Remember, there's a decimal here. How about this last 0? Is it significant?
Yes.
Okay. It is significant. It is significant because it is preceded by a non-zero in the number. Okay, so this one is significant because it's preceded by a non-zero. This one is significant because there is a decimal. So that's a total of 5 sig figs. Now, 9.0 times 10 to the negative third power. 9.0 times 10 to the negative third power. You're going to have to unravel this one a bit. Okay? So if we convert this into a real number, is my number going to be less than 1 or more than 1? What tells me? The negative exponent up here, the negative 3, right? So this number is going to be less than 1. So we need to move our decimal 4 spaces to the left, correct? Okay, so 9.0, 3 spaces. There's 1, 2, 3 spaces to the left. What do I do with these blank spots here? Put zeros in there. So my decimal goes here in front of these 2 zeros. So we're actually looking at the number like this. We can put a 0 here in front to make it more clear. Okay. So, oh, that just looks confusing. Let me just erase this and get it out of the way. How many sig figs are in this number? 2. Those of you that are saying 2, how did you arrive at that? What is significant and why? Are these 3 zeros here in front significant? Why not? Because why?
There's not another non-zero.
Okay, so it's not preceded by non-zeros. Okay, let's go back to the 9 0 here. The 9 is significant. Why is this last 0 significant? Okay, it follows a non-zero number, and also zeros to the right of the decimal that end a number are always significant. So it ends the number to the right of the 0, or the right of the decimal. So there are 2 sig figs in this one. Okay, last one, 9.010 times 10 to the negative second power. Is this number going to be more than 1 or less than 1?
less than 1.
How do you know that? The negative number, right? So, how many places do we need to move our decimal? 2 places. So, 9.010. If we move our decimal 2 places, that's 2 spaces to the right. That leaves 1 blank spot. Fill it in with a 0. So, our number then becomes 0.09010. And we can put a 0 here in front as a placeholder to make it more obvious. Okay. Now, are these 2 zeros significant? No. These are not significant. Okay? They're not preceded by a non-zero number, just like in our example above. How about this 9? Is it significant? Okay. How about this 0? How about the 1? Why is this 0 significant? It's between 2 non-zero numbers. Okay. How about this last 0? Is it significant? Why? It's preceded by a non-zero. It's also to the right of the decimal, and it ends the number. Okay? So there are 4 sig figs in this number. So when we convert numbers in scientific notation to real numbers, numbers in scientific notation to real numbers. If you look at the exponent, okay, that's going to tell you whether your number is less than 1 or greater than 1. If you have a negative exponent, is your number less than 1 or greater than 1? Your number is less than 1, right, for this first one? Okay, so less than 1. How about the second one? Is it less than 1 or more than 1? More than 1. How about the third one? Less than 1 or more than 1? Less than 1. And this last one, less than 1 or more than 1? More than 1. Let's do the first two. Let's do these two that I've circled that are less than 1. 6.721 times 10 to the negative third power. How many places do I need to move my decimal? 3 spaces, and it needs to go left because our number is less than 1. So 6.721. If I move my decimal to the left 3 spaces, that's 1, 2, 3. Okay. These blank spots, I fill them in with zeros, and I add a decimal here. Okay. So your answer becomes 0.006721. Some of you, when you wrote your answers on the worksheet, you left them in this form with the arrow at the bottom, and that just makes it more difficult to read, more difficult to see where you're actually putting your decimal. So if you just rewrite it very neatly over to the side, that helps a lot. 8.955, oh, sorry, we're going to skip the second one and go down to the third one. 1.817 times 10 to the negative 6th power. How many places do you move your decimal? 6 spaces to the left. So 1.817. 1, 2, 3, 4, 5, 6 spaces. Oh, it's going to be a tight squeeze. So 1, 2, 3, 4, 5 zeros, and then you have your decimal. So if you rewrite that neatly out here to the side, it looks like this. 0.1, 2, 3, 4, 5 zeros. 1.817. With numbers like this, it's really easy to see why using scientific notation is important. If you had to say this number over and over in a presentation, or you had to write it over and over in a lab report, it would be kind of difficult to make sure you had all the numbers the same, the correct number of zeros. Okay, so let's do 8.955 times 10 to the 5th. Is the number going to be less than 1 or more than 1? More than 1. And you know that because the exponent is positive, right? A positive exponent. So 8.955. If we move the decimal 5 spaces, that's going to be 1, 2, 3, 4, 5. You have 2 blank spots, so you can fill those in with zeros. Okay, so this number, when we write it over neatly, becomes 895500. Put in your comma. You have 895,500. 895,500 for that one. Last problem we have on here, 1.242 times 10 to the second power. Is it more than 1 or less than 1? It's more than 1. You know that because your exponent is positive. You need to move your decimal 2 spaces to the right. So 1.242. Move it 2 spaces to the right. So your new number becomes 124.2. So these are our last examples for today, real to scientific notation. First number, 393.9. 393.9. How many numbers do we need to the left of our decimal? To the left of the decimal. It's a number between 1 and 10. When we write this in scientific notation, we need only one number to the left of the decimal. So 393.9 becomes 3.939. Okay, so it's a number between 1 and 10. And we multiply by 10 to a power. Now we just have to figure out what that power is. So we look at where our decimal originally started, and we see how many spaces we had to move it. That's 2 spaces, right? So our power is 2. Is the number positive, or excuse me, is the number above 1 or less than 1? Okay, our number is above 1, so our exponent is positive. So there is your answer, right here. 3.93 times 10 to the second power. Let's look at the next example, 0.000005832. 5. 5 to the right of the decimal. Okay? What's our first non-zero digit that you come to? 5. So, when you write this in scientific notation, it becomes 5.832 times 10. And now we need to determine how many spaces we moved our decimal. 1, 2, 3, 4, 5, 6 spaces. Is our number more than 1 or less than 1? It's less than 1, so our exponent is negative. So 5.832 times 10 to the negative 6th power. Okay, looking at the next problem, 0.04844 in scientific notation. What's your first non-zero digit? 4. So we have 4.844 times 10. And to determine which power it is, 2 spaces. Oh. Now, our exponent should be negative because our number is less than 1. Last problem, 54,350. 54,350. What's your first non-zero digit? 5. So 5.435 times 10 to the 4th power. Is it positive or negative? Positive. Okay. One thing that students have asked me with example problems like this third one, 0.04844, is do we have to include these last digits? Well, yeah, you need to. Because if you multiply 4.8 times 10 to the negative second power, you're not going to get this number, right? You're not going to get 0.04844. You're going to get 0.048. So that is not equal to that number. This, however, including the 4, that is equal to 0.04844. Got it?